Chapter 8, Inequalities Test Review. Number 1, which of these numbers, 7, 8, or 9, is the solution of x minus 5 is greater than 3? So when I look at this, I have x minus 5 is greater than 3. I'm going to try each one of these numbers to see which one makes it a true statement. So I'm going to take out my x variable. I'm going to put in each of these numbers. So I have 7 minus 5 is greater than 3. 8 minus 5 is greater than 3. 9 minus 5 is greater than 3. So when I look here, I have 7 minus 5, which is 2. Is 2 greater than 3? No. 8 minus 5. 8 minus 5 is 3. Is 3 greater than 3? No. That's equal to, so it's not part of the solution. I try the last one, 9 minus 5, which is 4. Is 4 greater than 3? Yes. So I know that x has to equal 9. When I look at example 2, it says to complete the table. So this is my x value, here's my y value, here's my rule. My rule says 2x plus 5. Anytime I have a number and a variable side by side, that tells me to multiply. So I have 2 times x plus 5. So here's my x numbers. I'm going to take out my x variable here in my rule and put in the value. So I have 2 times 4 plus 5. So 2 times 4 is 8. 8 plus 5 is 13. I do the same thing with 5. 2 times 5 plus 5. 2 times 5 is 10. 10 plus 5 is 15. Oh, the next number is not there. So I have to work backwards with 21 to find my x value. So what I need to do is do the opposite of this right here, because I'm going backwards. So I'm going to take 21 minus 5. 21 minus 5 is 16. And then I'm going to divide that by 2, because opposite of multiply by 2 is to divide. 16 divided by 2 is 8. So I double check. I take 2 times 8 plus 5. 2 times 8 is 16, plus 5 is 21. That's my rule. For these three, for each function table, we have to write the corresponding question in the space provided. So here I have my choices. So I can either try each one of these and put the x values in and solve for y, or I can look at just simply finding my rule. In the first one, I have 8, I have 1, and y is 8. So I'm either adding 7 or I'm multiplying by 8. So I look at 2. 2 plus 7 is 9. That one works. Let's try and multiply. 2 times 8 is 9. No. 2 times 8 is 16. So I know that one doesn't work. Let me try 3. Is 3 plus 7 10? Yes, that works. Is 4 plus 7 11? Yes, that works. So my equation then would be here, whatever x is, x plus 7 equals y. If I look at number 4, I have 1 to 5, which is 4. I add 4, or I'm multiplying by 5. 2 plus 4 is 8. Nope, that one doesn't work. 2 times 5 is 8. Nope, that one doesn't work. So I know that neither one of those have to work. So that means that it has to have a variable and multiply by it. So I look from 5 to 8. 5 to 8 is plus 3. So that means that I have to multiply x times 3. So if I multiply 3 times 1, that would be 3. What do I have to do to 3 to get 5? That would be to add 2. So in this equation, it's 3x plus 2 equals y. Again, I can try the different numbers. We'll do that one for this one. So number 5, 1 and 2, 2 and 7, 3 and 12, 4 and 17. So I'll go here. Is x plus 4y. So 1 plus 4, is that 2? No, so that one does not work. Let's look at the next one. 5 times x minus 3. So 5 times 1 is 5, minus 3 is 2. That one works. So does it work for the next one? 5 times 2 is 10. 10 minus 3 is 7. Yes, that works as well. Let's try the last one, because we know this one works. Well, let's try this one. 7 times 1 is 7, minus 5 is 2. Ooh, that one works too. Let's try 2. 7 times 2 is 14. 14 minus 5 is 9. Oh, that says 7. So I know that one doesn't work. So this one here for number 5 has got to be 5x minus 3 equals y. Number 6 and 7, we have to write an inequality to represent each situation. So when we write our inequality, we go through and we underline everything that we understand. So anyone under the age of 12 cannot attend a movie. So let's go back. Anyone under the age of 12. So age of 12, anyone, and the words in between are under. So if you or anyone is under the age of 12, under would be less than 12 cannot attend a movie. It's always going to be a variable and then that number. Here's my number, here's my variable, then the inequality. It says Jonathan must work at least 4 hours. So Jonathan is who we're talking about. He must work at least 4 hours. So I know Jonathan, that's our variable, must work at least 4 hours. So that means that he has to work 4, but he could work more. So that at least means greater than or equal to 4 hours. So at least is always greater than or equal to. Something always good to remember when talking about inequalities. So here we have to solve each inequality. So I have d plus 9 is less than 15. So to solve, again, I want to get my variable by itself. So I'm going to subtract 9 from both sides. 9 minus 9 is 0. They cancel out. I'm left with my variable d. Less than sign. 15 minus 9, which is 6. Okay. Number 9, g minus 12 is greater than or equal to 4. So again, if I want to get g by itself, I want to do the opposite of subtract, which is to add 12 to both sides. 12 minus 12 is 0. I'm left with g is greater than or equal to 4 plus 12, which is 16. Number 10, 3e is less than or equal to 24. That's multiplying, so the opposite is to divide. 3's cancel each other out. I'm left with e is less than or equal to 24 divided by 3, which is 8. And the last one, which is 11, h divided by 7 is greater than 4. The opposite of divide is to multiply. I'm going to multiply by my denominator. 7s cancel out. I'm left with h is greater than 4 times 7, which is 28. So here we're going to graph the inequalities on a number line below the problem. So number 12, d is greater than 4. So to solve, I find the number 4, I put my circle on it. If it has just the greater than sign, I have an open circle. I need all numbers greater than 4. Notice in how my greater than sign points to the right. So this means all my numbers to the right are greater than 4. Number 13, g is less than or equal to negative 1. I find negative 1. I put a circle around it. I look at my inequality. Is there a line underneath? Yes. That means that it's equal to, so I shade in my line. My arrow is pointing to the left. It's all numbers less than, so less than would go to the left. On number 14, c is greater than or equal to 0. So again, I go to 0. I put my circle. I look at my inequality. It's got a line underneath. That means that it needs to be shaded in. And I'm looking at all numbers greater than 0, which would be pointing to the right. And number 15, h is less than negative 3. I find negative 3 on my number line. I put a circle around it. Is there a line underneath? No. So it's an open circle. All numbers less than negative 3, that would be pointing to the left. On number 16, we want to use words and symbols to describe the value of each term as a function of its position. In other words, what's the rule? Okay, so what is the rule? Well, go from 1 to 8. I can either add 7 or I can multiply by 8. So I check 2 and 16. 2 plus 7 is 9. That says 16, so I know that that one doesn't work. 2 times 8 is 16. That works. Let me try 3. 3 times 8 is 24. Yes. And 4 times 8 is 32. So what's the rule using words? We are multiply by 8. That's our number. And what is the value of the 13th term? So if this number up here was 13, how would I find the number down below? I would use my rule, which is to multiply by 8. And I would go 13 times 8 equals 104. And so 104 would be my answer. (18) and 19, it wants you to use the information in exercises 18 and 19. An adult male zebra eats about 19 pounds of vegetation each day. So write an equation to find P, the total number of pounds of vegetation an adult zebra eats in D days. So we're trying to find P. That's the equal sign, right? So it equals P. Well, what do I have to do to find the total number of pounds? I have to multiply 19 pounds every day. So 19 times D for days. That's my equation. When it tells me to find P, that's what it equals. It's always on that side. 19. Complete the table to show the relationship between the number of pounds P an adult male zebra eats in D days. So as we set up here, 19 pounds for 1 day. In 2 days, it would be 19 times 2, which is going to be 38. And in 19 times 3 is going to be 57. So I multiply those days, simply take out my variable D and put in those values. So now I want to go back, and here we're going to graph this situation. So here, y equals 1.5 times x plus 1. So if x is 0, I have 1.5 times 0 plus 1. 1.5 times 0 is 0. 0 plus 1 is 1. I multiply 1.5 times 1, and I add 1. 1.5 plus 1 is 1.5, plus 1 is 2.5. And if x is 2, 1.5 times 2 plus 1, 1.5 times 2 is 3. 3 plus 1 is 4. So here's my function table. So now I'm going to use my order pairs of x to y and graph my data. So if x is 0, y is 1, and I put a point. If x is 1, y is 2.5. So I start at 0, I go over to 1, up to 2.5. And if x is 2, I go up 4. So I start at 0, I go over to 2, and up to 4. Number 21. Y equals 3x minus 3. So 3x minus 3, that tells me I'm going to multiply 3 times whatever x is. So if x is 1, I have 3 times 1 minus 3. Well, 3 times 1 is 3. 3 minus 3 is 0. So I try the next one. 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is 3. And the last one, if x is 3, 3 times 3 minus 3. 3 times 3 is 9. 9 minus 3 is 6. So then again, I graph my ordered pairs of x to y. If x is 1, y is 0. So I start at 0, I go over 1, up 0. So that means my dot is on the x-axis. If x is 2, y is 3. So I go start at 0, over to 2, up to 3. And if x is 3, y is 6. I start at 0, over to 3, up to 6. The extra credit, it says Marie claims that all of the values of x that make x plus 4 greater than 10 true are also the same values that of x that makes x plus 6 greater than 12 true. Is she correct? Well, I know that x or 6 plus 4 is 10. So that 6 doesn't work. So let's try the numbers 7, 8, and 9. If x equals 7, 8, and 9, x plus 4 is greater than 10. If x is 7, 7 plus 4, is that greater than 10? Yes. Is 8 plus 4 greater than 10? That's 12. 12 is greater than 10. And 9 plus 4 is greater than 10. 9 plus 4 is 13. 13 is definitely greater than 10. So let's try x plus 6 is greater than 12. we're going to use those same numbers. Is 7 plus 6 greater than 12? 7 plus 6 is 13. 13 is greater than 12. 8 plus 6 is greater than 12. 8 plus 6 is 14. 14 is greater than 12. And 9 plus 6 is greater than 12. 9 plus 6 is 15. 15 is greater than 12. So is Marie correct? Yes, she is. And by showing your work, that justifies your answer. Please study for the test. Your test will be on Thursday. Please go to Clever, and in Clever, go to McGraw-Hill. Once you're in McGraw-Hill, click on the dark blue tab where it says Mathematic Practice Handbook. Click on Chapter 8 in that drop-down menu. Go to Lesson 1. That's on the right-hand side. Over to the right of that, there's a box that says Lesson Resources. Click on the right arrow until you get to the red self-check. Click on it, and there are self-check quizzes there. There are 5 problems that you should do for each of those 7 lessons to practice.